Welcome to another workshop video from Touro University. We're excited to cover today's workshop that's going to cover cloud computing and cybersecurity. Please welcome Beruz Korsandi, who will be hosting today's workshop video.
The title of this presentation is Cloud Computing and Cybersecurity. Why did I pick this particular topic? You probably have noticed in the world of IT, there are three areas that are in main focus by most of the large companies, mid-sized companies, and small companies alike. One is called artificial intelligence, and everybody should know that. The other one is cloud computing, and the other one is cybersecurity. In this presentation, we are going to be discussing two of the three. Now, the reason this particular icon was suggested is because if you think about it from cloud computing, as you're going to hear in a short while, there are three main components: infrastructure as a service, platform as a service, and application. And what you see here in this diagram depicts essentially what cloud providers are able to give you as a tenant, as a client. So, and you can see that they support a variety of devices, end user devices to connect to them, whether it is mobile phones, whether laptops, tablets, desktops, or even servers can connect and access and leverage the services that are offered in the cloud. So what are we going to be talking about in this presentation? Today's agenda, we're going to go through a quick introduction to cloud computing. We're going to touch base on some cloud terminology, understand some basic terms. We'll then talk about the different ways to deploy cloud. There are specifically 4 cloud deployment models. We'll talk about the 3 different cloud service models, which is talked as a service. We discussed this issue of data sovereignty, which is very important from a security perspective. We'll discuss what's the security challenges associated with cloud computing. And then we'll talk about standards and regulatory requirements. If you're going to move certain workloads to the cloud, you need to be aware of, within your industry, what regulations are required to be met. We'll then talk about some best practices to secure computing in cloud. That means if I'm running my workloads, if I'm leveraging as a service models in the cloud, what best practices should I follow? And we're also going to talk about Internet of Things. All the IoT devices are popping out here and there, and why would cloud play a role in its deployment and support? Soon you're going to find out that, hey, it does play a good role. So without further ado, let's go to the definition of what's cloud computing. NIST, National Institute of Standards and Technologies, which is a division of the United States Department of Commerce, and they are the guys and gals who put together the standards of computing for the entire United States government. They came up with this definition. They say this is cloud computing is a model for enabling existing or being anywhere at the same time, convenient, on-demand access to a shared pool of resources. So that's a loaded statement. What that essentially means is that cloud computing provides you with accessibility to services, accessibility to network, accessibility to different type of resources such as networks, servers, storage like disk, various applications, as well as various services. So, and essentially this is done because you can rapidly provision those services. That means if you need it, you don't have to wait for a long time. It can be released with minimal management effort. That means if I want to make it available for my end users, there is not a lot of effort required. Of course, you need to understand what you're doing, but there's not a heck of a lot of effort required. As well as minimal interaction with the service provider. So that essentially means that the service provider is going to give you the tools, the utilities, whether they're graphical user tools or whether they are command line tools. That means that you can leverage any of those to interact with the environment. So there is a link that I've included here I recommend that you bookmark this and download this PDF document, which is available free of charge by NIST. So the key thing to remember is that the cloud computing system refers to a set of IT resources. These resources can be software, these resources can be middleware, these resources can be hardware. They are designed to be allocated ad hoc. Ad hoc means as you need it, when you need it. That's really the definition of allocated ad hoc. And the whole idea is for you to be able to run your business applications, the applications that you depend on, instead of being assigned to a set of what we call static applications, which is the old traditional client-server computing model used to be. So again, ad hoc means the facilities that the cloud computing company provides are available on an on-demand basis. You know, you subscribe to Netflix. Netflix is an example of an on-demand. The cloud computing facilities are also available on demand when you need it, as well as providing users with a cost that is commensurate with their usage. What that means is, essentially, when you're dealing with a utility company, water company, gas company, electric company, they charge you only for what you use. Cloud is no different. They charge you based on the amount of disk storage, based on the amount of CPU you run, based on the amount of how many core CPUs are assigned, how much RAM is assigned. Based on that, you are being charged. Not only that, they provide you with rapid deployment as well as scalable resources. Scalability is a very important concept, ladies and gentlemen. Scalability essentially means that as your needs grow, the resources in the cloud can also scale up. And if you don't need it, they can be scaled down. So cloud is a good metaphor for this sentence. Cloud is actually a network of data centers. Where are these data centers located? Spread across the United States, spread across multiple geographies, multiple continents even. And by the way, they continue to increase. If I just go there and tell you that, for example, right now, Microsoft has, for example, 55 data centers globally supporting their Azure cloud. In another couple of weeks, that number is going to change because they continue to add new data centers over and over and over again. So what do we store in these? What do we do with these data centers? These data centers are used to actually store information as well as compute information. And the key thing in here is they're accessible through the internet. Let's continue with what's called a cloud paradigm shift. Thanks to cloud computing, our computing paradigm has changed. In fact, thanks to cloud, now we have a new consumption model. Now we have a new delivery model. Consumption talks about how we consume services. How do we consume disk storage? How do we consume CPU? How do we consume database applications? How do we run middleware applications that are required to make an entire application stack work? It's also a new delivery model. How do you deliver the applications? These are modern type of applications that typically depend on a browser. You fire up your browser, you launch Microsoft 365, which is an example of an application in the cloud. And essentially, they are a modern alternative to what we used to do. What we used to do, if you recall, companies used to build their own raised floor data centers, massive amount of air conditioning because it just gets very hot. You have to pay for electricity. You have to pay for cooling. You have to purchase the hardware. Cloud computing is changing that paradigm. And in fact, going back to COVID-19 pandemic days, COVID pandemic ended up accelerating adoption of cloud computing by companies. Folks would meet in the IT department. They figure out, okay, what do I need? I need 3 servers. Okay, add 16 gigs of RAM, these many cores, etc. And you would go and purchase that hardware. Now, sometimes you would see that during the course of running this hardware only gets about 3%, 4% utilization. You might say, well, that's great. But guess what? That's a big waste of your investment. You purchase that hardware at such an expensive price, and you're only getting 3%, 4% utilization. So that's not a good thing that we're talking about. Thanks to cloud computing, we can actually consolidate our footprint. Do we need as much capacity on our data centers on premises? As well as how do we share data applications and hardware with various other departments internally, with our customers, as well as our vendors. Another terminology that cloud computing introduced is a term called multi-tenancy. That means having multiple tenants. This is actually goes back to the early 60s. Why 60s? Because back then, IBM had created mainframes. Mainframes were these behemoth computers that used to be water chilled, taking up 2, 3, 4, 5 rooms, a lot of space. And in fact, that's how we used to do. And they're still around, but not to the capacity that they used to have back then. Their footprint has become much smaller. But nevertheless, what companies would do, because mainframe computers are very expensive, they would rent or lease space on the mainframe. So they would be able to run CPU, they would be able to run RAM, and by renting it, they would be able to reduce their computing expense. The idea of multi-tenancy, which applies to cloud, essentially is meant to partition the data and configuration from one client to another, and from the client as well as the cloud provider. And we're going to come up with some examples here so you can see what we're talking about from a multi-tenancy perspective. This multi-tenancy has evolved. You probably have heard, if not used already, application in the cloud. In fact, if you are a student or a faculty member at Touro University, you use Office 365 quite a bit. Well, guess what? That is an example of a software as a service application that we are subscribing to. Dropbox is yet another example, and there are countless other ones as well. I mentioned to you earlier tonight about the utility service. Why is that such a big deal? Again, going back to the way we were talking about how traditionally companies used to purchase computing power, organizations have had to spend a lot of money upfront. So I need to buy 10 servers. Each server costs, I make a number, $15,000. 10 of that, we have to put up $150,000 money upfront to pay for those servers. Well, because of cloud computing, our applications, our resources are residing in data centers that typically we don't control. The cloud provider does. And we can dynamically provision those resources. That means if we don't need them, we won't use them. We don't get charged for them. If we need them, we use them and we get charged according to the usage. Hence the term utility service. And the key thing is this stuff is being shared by multiple clients, by multiple tenants. The purpose of this utility service is to benefit from economies of scale. Cloud advertises the concept of pay as you go. The idea of pay as you go helps chief financial officers, the folks that are responsible for managing the books for a company, for an organization, so they can figure out, okay, this is going to be my expenses month of May. This is going to be my expenses month of June. This is going to be my expenses for the month of July, so on and so forth. So you can plan what your expenses are. Remember, you don't have to put any money up front. That used to be the historical way. With the cloud computing, we can now better predict these costs. A CFO or CTO is very happy because he does not have to make a huge initial investment on the infrastructure, as I just mentioned. Okay. So even though this is a computer science related discussion, even though this is a technical discussion, we have to talk about some non-technical stuff, especially related to finance. Those of you who have a little bit of a finance background should be able to feel at home for slide number 6. We are going to discuss the difference between operational expenditure and capital expenditure. You notice it's quite relevant to the concept of cloud computing. First of all, definition. Capital expenditure, which we call a CapEx, means that you spend money on physical infrastructure. Physical infrastructure involves servers, routers, switches, access points, cabling, workstations, etc. And then what you do is that from a business perspective, you deduct those expenses from your tax bill, not right away, but over time. This is very important. So essentially, CapEx is classified as an investment where the value goes down over time. And why are we talking about it? Because traditionally, and even until now, those companies that build their own data centers, those companies that manage their own data centers, they have been using the model of CapEx. So flip this over 180 degrees, you create what's called operational expenditure. Operational expenditure means we are going to be spending money not only on products, which is hardware, but also on services. The services that a service provider gives you. But the difference is we build for them immediately, which means we can start deducting that expenditure from our tax bill within the same year. So from a CFO perspective, he or she would be very happy, delighted, in fact, with the concept of OPEX. And because there's no upfront cost that you have to pay, you only pay the monthly fees. And the monthly fees are fairly predictable. They show you what you need to do. CapEx has been the model for traditional IT. OPEX is how you procure and how you consume services in the cloud. And as a result of migrating, moving your workloads to the cloud or adopting cloud computing, we are shifting from CapEx to an OPEX model. Now you see why we have had to have this financial discussion here. Just because we're shifting from CapEx to OPEX doesn't mean we are living in a wonderful world. You still can run into unexpected costs if there's no accountability, if there's no proper management, if you don't understand or see what's going on with our expenses. So everything still has to be accounted for properly. All right. What are the 4 different cloud deployment models that I promised we're going to discuss? The first one and the most prevalent one is called a public cloud. Just because it's called public cloud, it doesn't mean it's free. Although companies like Microsoft offer their Microsoft Azure on a trial basis. They give you initially a $200 credit or 1 month, whichever one comes first, that you can try it and test it, and you don't have anything to lose. But generally, they charge you on a pay-per-use model. You become a subscriber or you become a tenant, and within your tenant environment, which is inside the cloud, which we call it the VPC, virtual private cloud, you add resources as you need. For example, maybe I need a VM, a virtual machine with 2 CPUs, with 32 gigs of RAM and SSD type drives. That's what I mean by adding, and then maybe I don't need additional SSD. I can just delete my data and remove the disk from my system. So that's what it means by based on your subscription. The opposite end of public cloud is private cloud. Why do we call this thing private? Because a private organization, implements that cloud within their own internal enterprise, almost like putting it in their own data center. So who uses that? Only the organization's employees and perhaps their subcontractors and partners. Now, that means that obviously that organization has to go ahead and deploy networks, deploy the servers, deploy any application specialists. Does that mean private cloud is going to be more expensive than public cloud? Absolutely. Well, automobiles introduce hybrid engines. Cloud also has hybrid. Hybrid cloud essentially means that an organization has some of their services and resources in the public cloud, and they have some of the other services and servers running on their own environment, on their own data center. That means that they have some kind of a relationship with the cloud provider, as well as specialists that are going to maintain their own in-house premises. So what this model provides is a best of both worlds. That means services that probably would be too expensive for us, such as email that we want to use, we can subscribe to it on the public cloud. Services for things that are special applications that may not have to come updated. They are not modern applications. They simply do not run on browsers, and they still rely on the old-fashioned client-server model. We can run it on our premises. And this configuration is a simple example of hybrid cloud. And the last one we speak about is called a community cloud. The reason we call it community cloud because that infrastructure is shared among organizations that have some common computing need. That means they might have to share their ledgers with each other. They might have to share their billing systems with each other. So they have some common needs. Obviously, before any community cloud can be set up amongst the organizations, there has to be very tight security controls in place. Security policies have to be abided by, have to be discussed and agreed by all the organizations. And who is going to manage this environment? How is it going to be managed? From who? By who? Now, who owns the community cloud? Depending on the agreement that they had reached. It could be one or the multiple organizations, maybe even a third party is managing on behalf of these organizations. Is it on premises? Possibly. Is it off premises? Possibly as well. So all of these details need to be worked down among the cloud community cloud members. So obviously the question comes in, which of these cloud deployment models should I deploy? And as you're familiar with, as you've heard in the world of IT, the correct answer is it depends. It depends on what's your business requirements, what's your technical requirements, and perhaps what's your budget requirements as well. All of those play a major role. And when I say business, security and privacy would be one component of that business requirement. So let's talk about some characteristics of private cloud and public cloud. We kind of alluded to some of these already. When you're dealing with private clouds, the data, which is the most precious asset of the company, is owned by the organization and stored only on what we call on-premises, or we call it, better yet, internal resources. It's not on some third party, and only authorized individuals within the company can actually access the data. Flip it around 180 degrees. Public clouds means that the data that this company has is stored within secured facilities in the cloud, in some data center owned and operated by the cloud providers such as Microsoft, Amazon, Google, IBM, Oracle, etc., or even Alibaba as an example. I mentioned you the top 6. With public clouds, the attackers and disgruntled employees don't know where the actual data resides. So it becomes very difficult to figure out where the data resides. This can be good and bad. And whoever is your cloud provider has the responsibility to provide security as well as maintain the level of services in a contract. This is a very important point because when you sign up for public cloud, you sign up for a service level agreement. The service level agreement says that, for example, to deliver, as an example, SQL Server database to this customer, we are guaranteeing that this service is going to be available 99.99% of the time. So what happens if the service is available 99.98% of the time? For that difference of 0.01% of the time, the service provider has to issue a credit to the tenant. That's what we mean they have to maintain that level of service. And obviously, different services have different service level agreements. You need to look on their website to find out what it is. But the majority of the cloud providers, as a minimum, provide 3 nines availability. 3 nines mean 99.9%. And please notice that 99.9 is not 100%. They're quite different than each other. With public clouds, you grant access to essentially any location, and you got to be cognizant of the fact that your data is no longer transmitted within your intranet, which is your private network. It's actually transmitted over the internet. And because this is a public cloud, you as a tenant are dependent on the cloud provider or the vendor for the services that they provide, or for all the services that you have subscribed to. Does that mean that if the cloud provider's network goes down, or a server crashes, or the data center burns down, we are going to lose potentially that access to that machine, that's data? The answer is yes. So the question is, I talked about private cloud. I also spoke about traditional data centers. Why would you choose private cloud versus traditional data center? There's a very simple answer. The simple answer is, what kind of applications are you running? Are you running legacy applications that don't understand what virtualization all about? Are you running small set of applications where cloud could be an overblown environment for it? Then in that case, a traditional data center would be appropriate choice. On the other hand, when you're dealing with private cloud, this is going to be good for companies that need the speed at which public cloud provides the services, but also you need to be under control of your hardware. You want to be controlling security. You want to be controlling sovereignty due to regulatory reasons. Through a private cloud, similar to regular cloud, we have dynamic scalability, which means we can increase or reduce our resources as necessary, similar to public cloud. We provide a level of automation in terms of how services are configured and delivered to the users. And it would be considered to be lower operational overhead compared to older traditional data center. Whereas with traditional data center, you have full control of the hardware, but the bad thing is you need to have heavy investment in CapEx, capital expenditures. Scaling is typically done manually, and you have to do continuous maintenance. This is one thing I forgot to mention earlier. One of the big value propositions that cloud provides, remember, you have to continue provide maintenance. What kind of maintenance we're talking about? Patches that need to be applied, applications that need to be updated or upgraded. Servers might require service, and a component goes bad. Who's going to replace that? That's what I mean by ongoing maintenance. When it comes to choosing between private cloud and traditional data centers, private cloud wins, as you heard, when you need speed, elasticity, which is the capability of increasing or decreasing your requirements as we move along, as well as how efficiently you deliver services. Whereas traditional data center wins whenever you have to have absolute physical control, complete control over your resources and your applications. The most important trade-off is controlling of your important asset, which is your data. When I'm talking about safety of data, I'm referring to make sure that the data is properly encrypted, appropriate users can access it, making sure the data has not been tampered with. In the world of cybersecurity, we call that CIA, confidentiality, integrity, availability. So private cloud gives you the most control because it's under your eyes, under your control, under your domain, in your premises. But private cloud requires knowledgeable staff to manage this environment, to deploy this environment, and secure it, and support in the long run. With public cloud, your data resides in some third-party organization. We gave you examples of it: AWS, Azure, GCP, so on and so forth. Can we trust them? Obviously, a lot of companies have. And in fact, if you hear about the measures that cloud providers do to go on to protect the data, to make sure the data centers are completely obscure buildings that nobody can figure out what they are or who they belong to, you'll be amazed at the levels of security measure that they take to protect that infrastructure as well as the data. When you're dealing with a public cloud, the third party, which is the cloud provider, typically has a lot more knowledge and a lot more capability than us in protecting our data. And that's true. They have a lot and lots and lots of experienced staff managing, maintaining, and monitoring your environment. And as you're going to see in the next slide, with a public cloud, there are various service models that you can subscribe to. You can subscribe to 1, 2, or 3 of them. So, before we get to that, you need to understand the 5 key characteristics of a cloud. Characteristics, traits have the same meaning. The first one is called on-demand self-service. I kind of touched upon this at the beginning of our conversation. Services are provided to you on demand whenever you need it. Self-service utilities, tools, GUI tools, command line tools are available for you to configure and run your environment. You can provide essentially ubiquitous network access, and that term essentially means that the service is available and exists everywhere and all at the same time. Location-independent resource pooling. Resources reside across various data centers, and an organization and a tenant that is subscribing to the public cloud can say, hey, I want to use the resources that are in this location. I want to use the resource in that location because one particular location could be geographically closer to some of our users. They tell you essentially where they reside. Like, for example, they say my data centers are in the US East. Sometimes they might say it's in Virginia, but they don't get any more specific than that. So you can pool those resources, make them available to your environment. We spoke about the concept of elasticity. If you think about a spring, you're able to make it elastic, stretch, and when you don't need it, it can go back. That's the same concept with cloud computing. And the best example I give you is I think about end of the month, perhaps, where you need to process, for example, paychecks, or end of the year, you need to process tax forms, or the beginning of the year, or end of your fiscal year. So that is the time that you need the most amount of capacity and computing power. And let's say that period runs for about a month. After a month, I do not need to use the same amount of CPU, the same amount of disk. So I wipe them out, I get rid of them, and I do not have to pay for the stuff that I'm not using. And pay per use essentially means I pay only for what I actually consume. Some more computing terms. There is a term called infrastructure modernization. What does infrastructure modernization mean? This is a term that talks about the process we go through to replace legacy hardware. Legacy hardware is like a hardware that we have sitting inside a data center, as well as legacy systems, as well as legacy applications, and consolidating all of these things in the cloud. Cloud is considered to be infrastructure modernization. In fact, one example I can give you is that Microsoft, as an example, no longer provides their email software on premises, such as Exchange Server. It used to be Exchange Server 2019, to the best of my knowledge, when you wanted to have your own email infrastructure on premises. But no, for the last 10, 15 years, they have been preaching, and in fact, they have said that, hey, you need to migrate your workloads to the cloud. And as I mentioned, when we introduced the hybrid model, most organizations essentially want to operate a hybrid model. They want to have some control over certain applications that cannot be migrated either because of security or because of the legacy status of that application. And again, another important thing you need to remember, in the cloud, we can scale. We call it scale in the cloud, up and down, as your needs increase. And you only pay for what you use when you actually use it. Whose responsibility is to provide security within the cloud? The answer is a shared responsibility security model. What that means is not only you as a tenant is responsible for the security of the data, the cloud provider is responsible for the security of the physical infrastructure, data center, guards, cameras, barbed wires, um, multiple different mechanisms, batch access into the data center, and even the servers themselves are identified, cameras on top of the servers, things of that nature. That's what the cloud provider gives. Another important thing that we're going to be discussing is compliance with regional regulations. That means, as part of your security and governance, and in fact, it's a very important part of cybersecurity discussion. Every industry is subject to a number of regulations. Those of you who have taken courses with me, you know that I have beaten this issue to death. In fact, there are some common regulations that you need to be familiar with. The first one is called HIPAA. If you have ever gone to, God forbid, to a hospital or gone to a doctor or a facility, medical facility, you usually are required to sign some forms, and the provider needs to be aware that they are under HIPAA regulations. HIPAA is a U.S. federal statute. It went into effect about 30 years ago. And its idea is to protect patient medical records, patient health information. And unless the patient gives their consent or they are aware of it, the facility is not allowed to release that sensitive patient health information to other people. So if you are a hospital or medical facility and you're storing your data in the cloud, be aware that you're subject to HIPAA. Make sure you have the proper security measures in place so you're abiding by that particular regulation. Sarbanes-Oxley, shortly called SOX, goes back to 2002. I don't know how many of you remember when Enron failed. And in fact, Enron went bankrupt, and a lot of people probably lost a lot of money in that deal. The Sarbanes-Oxley Act of 2002 essentially mandates reforms to how companies disclose their financial health. And this pertains to companies that are publicly traded, like in the stock market, New York Stock Exchange or NASDAQ as example. And the idea of this is to cover auditor independence, corporate governance, and any important financial disclosures. So you need to make sure that this applies pretty much to every company, not to any particular industry. PCI DSS pertains to the payment card industry. Companies such as American Express, MasterCard, Visa, Discover, they need to abide by these rules, by these regulations. And essentially what PCI DSS does, it enumerates what the requirements are that payment card industry players have to meet in order to secure their networks. Remember, there's literally millions, billions and billions of transactions taking place on a daily basis with people charging their card, and they need to have appropriate measures in play to protect that credit card data, that credit card information, so that they're properly secure and they're properly securely stored. FERPA, which applies to higher education. Essentially, it's called Family Educational Rights and Privacy Act. And essentially, that gives the parents the right to access their children's medical record or how they're going to have their records amended as required. And something that you probably have heard for those people coming from Europe, Europe deployed this thing back in 2018, the European Union, I should say, deployed this. And by far, GDPR is the toughest privacy and security law in the world. And that essentially means that personal data belonging to anyone cannot be processed by an entity unless they have a legal basis to do so. If they don't, they will be subject to millions upon millions of euros in penalties. So, after all of that introduction, why would we want to use cloud services? And if you look at this picture on the left-hand side, it gives you a general idea of why that is the case. It's a very simplified picture. It shows you that when the user wants to access services that are running on some back-end servers, his or her workload is coming from elastic IP into some load balancers. Load balancers are typically physical load balancers, and you can also configure logical load balancers as well in your environment. And load balancer decides, okay, if this server is, let's say, 90% busy and this server is 40% busy, well, the load balancer is going to balance the load accordingly. Or if the server has gone down, then we know we don't need to redirect our request over to server 2. This is one of the reasons why we leverage cloud. Specifically, there are 6 main reasons why we want to use cloud services. First one is called high availability, or we abbreviate as HA. HA is the ability to keep the service up and running for a long time and only very little downtime. Of course, it depends on the type of service that you're running. This is the situation where I was speaking about earlier, which says service level agreements. It pertains to HA, 99.9, 99.9. We call it 5 nines, 6 nines, 3 nines, etc. And essentially, if a component fails, there's typically a brief interruption, which involves the system detecting it and switching to a backup. That's how you set up a high availability environment. We then have fault tolerance. What does FT mean? FT essentially means that I'm able to tolerate fault. I'm able to remain up and running even when a component fails, when a component no longer functions. Typically, in the cloud, redundancy is built into the architecture. And as you can see here, you can think of it as this is a redundancy build. So if a component fails, such as a load balancer, there is another one. And guess what? Within each of these servers, we have multiple power supplies, redundant RAM, mirrored RAM. We also could have multiple NICs, not could have, we definitely have teamed network interface cards. 2, 3, or 4 cards that not only aggregate their bandwidth, but if one of them goes down, the remaining 3 or the remaining 2 or the remaining 1, they'll be able to continue function. That's the idea behind fault tolerance. With fault tolerance, there is 0 service interruption, 0 data loss. So this is a kicked up a notch version of HA. We already spoke about concept of scalability. This is with the ability to add additional resources or even remove those additional resources. Elasticity essentially takes scalability not in one direction, but also in another direction. Elasticity essentially means the ability to automatically increase resources, automatically decrease the resources. With elastic resources, we are matching our current needs and we add them or remove them as the needs develop. Elasticity is done automatically. That's the difference. You hear in the everyday life, you got to be agile. You got to be you got to be able to respond quickly to events, to act, to different things that are going on. So agility, as far as cloud is concerned, pertains to the ability to scale quickly. That means I can allocate cloud services very rapidly when I need it. And last but definitely not least, the concept of DR, or disaster recovery. You know, disaster is a situation where a company can no longer operate. Their IT systems can no longer be used. That's when the company declares a disaster. When the company declares a disaster, then they have to find out a way. Do we have a hot site? Do we have a cold site? Or do we have a warm site, as they call it in the industry? And essentially, the DR as applicable to cloud means what's my ability to recover from an event which might have taken down a cloud service? Am I subscribing to multiple cloud providers, which is the term called multi-cloud? And in fact, means that I not only have services with Google Cloud Play, I also have services with Amazon AWS, or even Azure as an example. So we touched on HA and FT, high availability and FT. This table is a very good summary, a very good reference as to what the differences are. So, from the downtime perspective, as you heard me mention, with fault tolerance, there's zero downtime. With HA, it's a minimal downtime. Complexity with fault tolerance is going to be very high because there are far too many components involved to make sure that we don't experience any outage, that we don't experience any downtime. Whereas relative to fault tolerance, the complexity with a moderate scale. And of course, you get what you pay for. Because you're going with zero downtime, because of very high complexity, the cost happens to be very expensive. And typically only reserve fault tolerance for very, very critical systems that cannot afford downtime even for a brief second. Whereas with HA, it is more budget friendly. So the reason I put this table here, ladies and gentlemen, is because you don't want to go apply blindly. Oh, fault tolerance sounds a good thing. I heard Professor Corsani mention that. Let's go make sure at work I tell my boss fault tolerance is a great thing. Well, did you evaluate what your budget is? Did you evaluate what your requirements are? That's extremely important. Data integrity. Remember, this is one of the three principles of secure cybersecurity I mentioned. With data integrity, it's quite possible, although unlikely, that you might lose data while I'm switching from the primary node to a backup node. Whereas with fault tolerance, the state is preserved exactly as it is, and there is no data loss. If you want to find an analogy to your real situation, an analogy of high availability, HA, would be a spare tire you have in your trunk. If you see a flat, well, you're going to lose some 20, 30 minutes until you jack up the car, remove the tire, bring the spare tire back in and put it in. And the analogy on the fault tolerance word, think of it as a twin engine plane. If one engine, or even a 747 that has 4 engines, even if 3 engines fail, the 747 can continue flying. So, what are some of the challenges of multi-tenancy? Number one is isolation. Because in a public cloud, there are multiple tenants, the one big challenge is to make sure we have isolated them from each other, meaning a tenant VM should not see traffic from any other tenant VM. The next one is performance. So if we are all could be sitting on 3, 4 companies could potentially be sitting on the same physical server and not know about it. What happens if one particular tenant is going to run a database application, another one is going to run a video, the rendering imaging application, and both of them are fairly CPU intensive. Each could have an adverse impact on the other one. Well, this is a challenge that the tenant VMs should have minimal or no impact to the other tenant VMs. Flexibility, which means multi-tenancy, having the capability of having multiple tenants within an environment, means that I have to quickly provision additional capacity as well as easily provision that additional capacity. More RAM, additional CPUs, additional disks on the fly. Remember, you cannot turn these servers off. While they're hot, while they're up and running, you need to do this. That's why we talk about flexibility. So some security considerations of virtualization. Remember, in a cloud environment, 99% of the time, events and users and applications are virtualized. The first one is, if you know a little bit about virtualization, you know that when we're talking about type 1 virtualization, we have the physical host, the hardware on the very lowest layer, which is the hardware. On top of the hardware, we have the hypervisor running. And I've given you the name of 4 latest and greatest hypervisors. AWS Nitro, which is something that AWS runs within their environment. Microsoft Hyper-V, which is something you can actually purchase with Windows Server 2025 or Windows Server 2022. And this is also used within the Microsoft Azure environment. VMware has VMware ESXi. And in fact, if you wish, you can even leverage VMware ESXi within these cloud environments as well. and Citrix offers Zen Server. So whether you're using any one of these, the product doesn't matter. If this host itself, which talks about a physical machine, or the hypervisor that is managing the virtualization, manages the different VMs that are running on top of it, is compromised, that means from that point on, I can start attacking every single VM that's running on top of the hypervisor. That's why you have to make sure your hypervisor is secured. Not only that, every individual virtual server that we have or different tenants have has to have its own separate security mechanism apart from the hypervisor. That means antivirus signatures have to be updated. Patches have to be updated. Applications have to be updated for all our software. Okay, so the question comes in from a cybersecurity perspective. How do cloud providers ensure data is not leaked between VMs? So we're talking about cloud provider, public cloud specifically. So if we're going to have, let's say, 3 tenants running on one physical server as an example, how do we make sure the data in one tenant does not leak into the other VMs? Notice I have 3 slides talking about this. The defense strategy that cloud providers have embraced is called defense in depth. The purpose of a defense in depth is to ensure that the data remains strictly isolated. How does this happen? Through implementing multiple layers of technology stack. These layers begin from the physical layer on the bottom all the way up to the application layer. That's by the way, defense in depth is the very important concept that companies such as Cisco, Microsoft, as well as others, including Amazon and Google, have also embraced. And then on top of that, we have a gold standard called confidential computing. What does confidential computing mean? With confidential computing, hardware ends up isolating data from the cloud provider and the hypervisor. So what does hypervisor do? It ends up assigning a slice of CPU time, a slice of RAM to each VM. Remember, the physical server has, let's say, 48 gigs of RAM, and the hypervisor that's running there that you don't control, whether you're running platform as a service, software as a service, or other things, or infrastructure as a service, you don't control the hypervisor. Hypervisor is being controlled by the cloud provider. The hypervisor ends up allocating a slice of that CPU and RAM to each VM. And in that process, each VM is going to think that, hey, I have the entire control of that machine. You probably have also noticed that when you go in the BIOS of majority of the modern computers and you look at the modern CPUs in the BIOS configuration, they typically come with either Intel VTX or AMD. These are general capabilities within the hardware. This is a hardware feature, and essentially the purpose of it is to help the hypervisor. Remember, we spoke about AWS Nitro, Microsoft Hyper-V, etc. The hypervisor will be able to enforce the boundaries between our different VMs, which means one guest VM is not going to be able to execute commands to peek onto another vendor. By the way, even if you run Packet Tracer or Network Monitor or Wireshark in one tenant, it's going to be impossible to see the data that's flowing across in another tenant. Now, even if VMs share the same physical cable, the data that each VM handles is going to be kept separate. How? Through 2 phenomena. One is called Virtual Private Cloud, or VPC. One is called the concept of SDN. Some of these concepts are addressed in GCON 200 and GCON 231, but we go over them very briefly here tonight. When we talk about VPC, and which is a concept that both AWS and as well as GCP as well as Azure have deployed, you're referring to a private isolated section within the cloud provider's network. Again, it's a private isolated section. You can think of it as a similarity if you create a separate VLAN, which separates you from other VLANs. Yes, they're all connected. We might be even connected to the same switch, but it's as if you're two complete different words. That's the same concept with VPC. Also, through software-defined networking. Essentially, through software-defined networking, we're representing our network through software. And the way that's done is that you separate the control plane from the data plane. What's the control plane responsible for? Is a system that actually decides where the traffic goes, how it goes, what speed, what priority. Data plane is the hardware that actually forwards the traffic, the data. So through VPC and SDN, they do their job of making sure data is not leaked. We also have a concept called encapsulation, which means when the data leaves a VM, a virtual machine, what the cloud provider, Azure, for example, does, it wraps up that data in a metadata. So there's a special header. What is that header? It uses a protocol that's called VXLAN. And that VXLAN includes a unique tenant ID. So the tenant ID, obviously, for tenant 1 is different than the tenant ID for tenant B. And I want to give you an appreciation of how this actually works. Suppose customer A, customer B are on the same physical server. Suppose both of them use private addresses, RFC 1918. Suppose both of them use the same RFC 1918 address, 10005. Does that mean that there's going to be a conflict? The answer is no. Thanks to encapsulation and a technology called VXLAN, and I have about 2-3 slides on that, we are able to completely separate these from each other. That means that I cannot see the other traffic at all. How does VXLAN works? It essentially relies on UDP. It essentially inserts the MAC address information. This is the way a VXLAN header works. So if you look at the top, you remember on the far right-hand side in a frame, what do we have? Frame check sequence. Our original layer 2 frame, remember layer 2 is at the MAC layer, is right here. Then we have obviously UDP at layer 4, IP at layer 3, MAC address at layer 2. What we have inserted here is this VXLAN header, which is 8 bytes, 64 bits. And what's unique about this is this VXLAN network ID. You notice that 4 bytes are already reserved for future use, and there are some flags for actual processing. So what distinguishes this is this VXLAN network ID. So what VXLAN does, it creates a layer 2 network that overlays a layer 3 network, which means now I'm encapsulating that VXLAN message that I'm showing you right here inside a new VXLAN tagged header, as you see here. And now, as you see in this picture, I not only have in layer 2, I also have layer 3, I also have layer 4. VXLAN essentially is a network virtualization technology. Its purpose is to extend layer 2 networks, MAC, over a layer 3 underlay using what we call MAC in UDP encapsulation. MAC in UDP encapsulation. Let me go back to this slide. So let's talk about VLANs and VXLANs. You know, whenever you have two switches, two layer 3 switches that you connect to each other, we create a trunk link, as you have learned probably in your Cisco fundamentals course, Cisco CCNA course. The purpose of a VLAN tag is to find out to what VLAN that data actually belongs. VLAN tags exist at a data link layer, which is layer 2. It's not meant to go across layer 3. VLANs themselves, when you started to configure it, back when you took your first Cisco course, they told you you're limited to 4,096 subnets. You said, wow, that's a large number. And guess what? If you're a cloud provider, that's actually a very low number. If you remember also, when we discussed VLANs, we talked about broadcast domains. That means within that domain, the broadcast does not go anywhere outside of that domain. If you extend the broadcast domain traffic over a wider area network connection, you essentially reduce the amount of available bandwidth. Because of VXLAN, you're able to get rid of these three limitations. How? We already spoke about how the frame structure is. With VXLANs, we can now have 16 millions of them within an organization's network. Wow. We go from 4,096 to 16 million. Quite a bit of order of magnitude difference. Also, VXLANs do not rely on broadcast. They rely on multicast, which means one to a group of many. Thanks to multicast usage, we reduce the bandwidth. So typically, your cloud providers implement VXLAN because they have to host multiple tenants. So what is this concept of network virtualization in the cloud? The idea of network virtualization is important because everything that a consumer, everything that a tenant sees is a software representation of physical devices. Remember, I mentioned we have no control over the physical components. We use a virtual instance of that. Network is another example. Network virtualization essentially gives you the capability to run multiple virtual networks on the same physical cable, on the same physical network. Because you're dealing with a virtual infrastructure, that means you also configure virtual switches. And for those of you who have taken fundamentals of, let's say, VMware server virtualization, you know virtual switch resides in software. If it's a physical server, it has 48 ports. Virtual switch could have also that many ports as well. I can assign ports to different VLANs. I can do the same thing with virtual switches as well. And essentially the same type of physical attacks that take place against our physical network, they can also take place against virtual networks as well. Remember that each VM within the cloud is assigned two IP addresses. One address is the customer address, which is the address visible within the virtual machines network. Who assigns this? The customer. The second address is what's called the provider address. This address is visible on the physical network that's assigned by the fabric administrator, and that is based on the physical network infrastructure. Now, we mentioned that there was public cloud, private cloud, community cloud, and hybrid cloud. Within each cloud, you have at least three different service models. The first one is called IaaS, Infrastructure as a Service. With Infrastructure as a Service, the cloud provider gives you the entire hardware platform, the data center. You can't walk into the data center, but you leverage the facilities within the data center. You, as the tenant, install your own operating system. They give you flavors of Linux, they give you flavors of Windows, and you pick and choose what operating system you want to install. The middleware, which is the software that's neither the application nor the operating system, sits in the middle, as well as the applications. What's the job of the vendor? And as far as an infrastructure service is concerned, to give it a data center and maintain the data center and the physical servers. So if I'm a company that needs to host its web servers with a third party, this would be an ideal situation because now the third party cloud company is going to give me the infrastructure that I require. PaaS, or platform as a service. Again, the cloud provider provides you the hardware platform, they provide you data center, they give you the software that runs on the platform, including the OS, as well as the middleware software. What's some examples of middleware? Database, web server software, Java virtual machine, development environments. So these are examples of middleware components. What are you as a client responsible for? You're responsible to install and manage your application, leveraging that platform. Maybe I'm a company that needs to develop application and test that application, and I just simply do not have the capacity nor the money to go buy servers and set it up in a timely fashion. That's why I subscribe to PaaS. SaaS, it includes the operating system, infrastructure software, and the application. Notice I've been giving you 3 examples of a Salesforce, Microsoft 365, as well as Intuit QuickBooks that you access through a web browser. We spoke about this concept of shared responsibility, responsible model. What does that mean? That means both the cloud provider as well as the tenant or the organization have responsibilities. And they need to understand the delineation between them. Who does what? And this is very important because, remember, we need to worry about data security. We need to worry about endpoint security. We need to worry about identity and access management, which essentially means authentication, as an example. All 3 of these happen to be responsibilities that the tenant owns. Who accesses my data? Which are the endpoints that access my data? Who logs on and who cannot log on, during what times they can log on? These are all decided by the tenant, hence the term delineation of responsibility. Here I have borrowed a slide from Microsoft, which deals with division of responsibility. And as you can see, anything to deal with physical data center, physical network, and physical hosts, typically the responsibility transfers over to the cloud provider unless you're running an on-premise solution. When you're running on-premise, you're responsible for everything for the entire stack. On the other hand, with IaaS, which is infrastructure as a service, in this example, Microsoft or the cloud provider manages the physical hosts, the physical network and data center. You handle everything from operating system and up. For PaaS, well, network control is a shared responsibility. Applications are also a shared responsibility. Identity and directory structure, I'm talking about, for example, Active Directory, some directory service in the cloud, or Azure Active Directory that's running in the cloud, as an example. But remember, accounts and identities, which are the user IDs, devices, and information data, regardless of what it is always handled by the client. So the dark blue indicates to you that this is all the responsibility of the client. This is a very important chart to understand as you migrate your workloads from on-premise to the cloud, who is responsible for what. So some quick focus on security. ISO has created IEC 27017. Why this number is important? Because it's actually a code of practice. It's an international standard. This is a standard that companies certify themselves against, and essentially provides guiding document. You can think of it as best practices. You can think of it as commonly accepted protection controls. Larger companies, in fact, have certified against IEC 27017. Why did I include that here, and why is it important? Because it talks about this shared roles and responsibility, which I call it a two-way street. How do we remove and return any assets that belong to the customer? What happens if you no longer want to subscribe to the service that the cloud has? How do we make sure that we get this stuff back? How do we protect the customer's virtual environment from the other tenants? What we discussed earlier tonight. Remember, with hardening, you remove unnecessary services from your environment, in this case, from your VM. So what are the VM hardening requirements? What steps you have to take to make sure your VM is hardened according to best practices? How do you administer the environment in a cloud computing situation? And how do you enable customers to be able to manage and monitor different activities? And how do you make sure that you align security management not only for physical networks, but also for virtual networks as well? There are also, this is not meant to be an eye chart, organizations look for various other guidelines. I only, in this previous slide, slide 28, I included the most prevalent one, but there are also other ones from security assurance, privacy assurance, all the way down to even independent verification. And we can spend a good 2 hours just simply talking about this slide alone. So NIST says you should carefully plan the security and privacy aspect of the cloud computing solution because there are lots and lots of security challenges. You need to understand what policies and procedures and what technical controls the cloud provider has in place. In fact, before you sign the contract, you can ask them for it, or you can go to their website and search for that information. I mentioned briefly that we're going to talk about data sovereignty. This is an important security concept because it talks about the concept that data stored in digital format, which is anything that you do with your computers, is subject to the laws of the country where that data is located. So that means that if your company is a multinational company in the United States, China, Germany, and the rest of the world, you need to be very careful how this data is being shared. If a user in China or Germany produces a piece of data, email, a document, a voice message, whatever, this data cannot leave that country, even though that data belongs to that organization. If you violate this, your company could be subject to massive amount of penalties or censorships for that matter. So what the security professionals need to do as part of their planning, they have to decide where is going to store the data. Where am I going to back up the data? Can I replicate a server from one country to another? The answer is no. Who has access to the data? Can some user from Europe access the data that's in the US and vice versa? What about encryption? Encryption at rest, encryption in transit. So remember, responsibility to meet data regulation falls on the organization as well as on the cloud provider. But data is ultimately responsibility of the client. I do thank everybody for joining us. I wish you guys all much success. Thanks for listening. I hope that you find value in this presentation.